Hello everyone, this is Dr. Mahmoud Al-Odeh. Welcome with another video of quality assurance. In this video, I will be talking about one of the 7 quality tools, which is the histogram. These quality tools, we use them for problem solving, and we still are in the planning phase. We need to spend much of time, a lot of time on the planning phase, because if you plan it the right way, you will reach to the good result, the best result that you could find. So in the histogram, it's a really nice diagram that's an easy to build as well, but it's effective as well to let you know exactly where is the majority of data centered. So let's read about it, and then we'll take an example and show you how to build a histogram. A histogram is a graphical summary of the frequency distribution of the data. A graphical summary of the distribution of the frequency distribution of the data. What does that mean? Like, if you remember the check sheet that we discussed in the previous videos, we talked about the check sheet, and whenever the defect happening occurred, you put a check mark. Now uh, we need to have that information. We need to take it into a higher level, and at that higher level we need to see, is this a normal data, where is the majority is. So for example, if you look into the grades in a class, I would say we look into the average. We say, okay, the average of the class is 90%. Most of the students achieved 90%, or average grade for this class is 90%, which means the majority of the students, they achieved a grade around the 90%. So we need to look into the summary of the frequency of the distribution. When measurements are taken from a process, they can be summarized using a histogram. The data are separated into classes in the histogram. So what is the difference between the histogram and the check sheet diagram or the bar chart or one of these chart that we use? This particular chart, the histogram, will categorize this data into category. Category 1 could be from 90 to 100. Category 2, that would be from 80 to 90. Category 3, from 70 to 80, and so on. So we divided the data on these categories in these classes. Each interval shows the total number of observations made in each separate class. So these are the data will be recorded in these classes, and these called also interval 1 from 90 to 100. Histogram display the variation present in a set of data taken from a process. So what is that exactly? It does show you the variation of the process. And we will go into deeper when we cover chapter 4 and 5, and we will be talking about the histogram and how we represent, how we read in the histogram. At this point, what I want you to do, at least I need you to be able to create the histogram. And it's very easy and simple, and I will show you in just a second how to do it. But eventually, the histogram, the middle of the histogram, that would be the average. If you go away from the average, that's variation. So your goal, your target should be the average in the center of this of the diagram. So let's take a look here. So if we say this is a histogram, as you see, the first category interval from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, to 80 to 90 to 100. And now the center of this, which is, I'm going to create a line here, and here in the middle of the histogram. So that would be the target. That would be the average of the data. And the histogram, we'll talk about it in more details, hopefully, next time when we talk about variation and the control charts. But this is basically what looks like normal. When we put the bill curve, it should the mean, the center of it should divide the chart into two halves. So this is what we say, what we call, this is normal. Half of the data is distributed on the right, the other half is distributed on the left. This is the normal, this is the perfect situation. This is where we need to see our data. Now, again, this is the target in here, about 45. This is the target. And in this target, what we need to do, we need to see the variation. So here is 5 points vary from the average. Uh, right here is also 5 points. So this is also will give us a tool to see how the data are away from the target. And again, our goal is to be here. That's where we need most of the data to be around uh, the around the mean. And the closer to the mean the data, the higher the peak will be. So that would be this way, for example, which means that more accurate. That's mean that you have a less variation, which means that you will reach to a 6 sigma variation, which is perfect. You will have a 3.4 defects per million parts, which is, that's the target. This is what we need. So we need, as much as we can, we need to narrow the data to be clustered around the mean. This is what our goal. Anyway, the histogram, it's a graph that will show you the frequency of the data, and it's classified into classes or organized into classes, intervals, and this will show you the variation in a process. How we could create a histogram. All right, in order to create a histogram, so what I want to do, I want to go open an Excel sheet, assuming that I'm going to give you a scenario here, which is uh, the scenario will be the length of a part, a specific part. I am producing a part, and I would like to see if I do have a variation in my process or not using the histogram. So what I want, I went to the process, I observed the process, and I took the observation of the process. I measured 100 parts. I did measured 100 parts. So I do have data for 100 parts here. As you see, that's the length of a specific part I have in my factory. And what we need to do, we need to create a histogram to see how far we are from the mean and if the process vary or not. All right, so that's is simple and easy. All you need to do is select the information from 1 to 100, only the information, not the number is on the left side. And you go to insert, and now on here on the chart, there is a function called histogram. You want to select that, and ta-da, that is it, the histogram. All you need to do is fix the format, make sure that this chart looks nice, bring it a little bit wider here, and now this is length of a part. All right, now, so what does that mean? That means, first of all, what you see here in the data, when you explain this, when you analyze this chart, you will say that the data is normally distributed. And the reason why is that? Because if you put a line in the middle here, you will see that most, like almost, I don't want to say exactly, almost the right side looks like the left side, okay? Um, so it is normally distributed or almost normally distributed. So that's good. Also, you will see how much variation you are away from the target. And it's also represent the classes, the intervals. So the first interval, these are the parts that with a length of 109.25 to 113.85. And you will see exactly how many parts are there. So we'll see 4 parts are in that area. So this is not, this is not the optimal. This is where you need the majority here. As you see, the majority is in this class right here, 123.05 to 127. So it's a range between 123 to 127. So that would be the majority of them. And they're also uh, more around the mean. So it is very helpful to give you a better idea on what's the process, the variation of the process, and we'll see if you have a really wide variation in that. Is the process normal or not? If the data normal or not? Uh, Imagine you're going to place the bill curve on the top, and imagine that there's a line in the middle here, and look into the process, look into the data if it's normal or not, and this will give you a better idea on what the data look like. With that said, I'm done with the histogram. Now we're moving into another tool that we're going to use, which is the scatter diagram, another useful tool that we use it for the problem solving tool. Thank you.